When quantities have values that can change, we represent those values with a variable. For example, Allison plants an orange tree in her backyard and periodically measures its height. Since the tree's height changes over time, we can represent the tree's height using a variable. Let h represent the orange tree's height in feet. We know how to interpret statements like h equals 6 because we carefully defined the variable's meaning. H equals 6 represents Allison's orange tree measuring 6 feet tall. As we mentioned, the value of h will change over time as the tree grows. Suppose Allison measures the tree at the beginning of spring and it is 6 feet tall, represented by h equals 6. At the end of summer, Allison measures the tree again and it is 9 feet tall, represented by h equals 9. What was the change in height? The tree's height changed by 3 feet, and we have a special notation to represent this. Delta h represents a value for the change in the tree's height, so in this scenario, we say that delta h equals 3. Whenever you see the symbol delta, you can interpret it as representing the phrase change in. Changes in quantities' values are a new quantity and are interpreted differently from the value of the original quantity. For example, let's compare the meaning of h equals 6 and delta h equals 6. H equals 6 means that the tree is 6 feet tall. Delta h equals 6 means that between two different measurements, the tree's height changed by 6 feet. So the tree could have been 10 feet tall and grew to 16 feet tall, or the tree could have been 12 feet tall and grew to 18 feet tall. Similarly, if h equals 8, it means that the tree is 8 feet tall. If delta h equals 8, it means that the tree's height changed by 8 feet. Delta h equals 8 doesn't say anything about the tree's height, only about how much that height changed. Let's represent the relationship between two measurements and the change in the measurements using words, in two different ways. The tree's initial, or starting height, based on some first measurement, plus the change in the tree's height equals the tree's final or ending height, based on some second measurement. We can translate this into symbols by letting h sub I represent the height at the first measurement, and h sub f represent the height at the second measurement, and delta h represent the change in height. Then h sub I plus delta h equals h sub f. Alternatively, we can say that the change in a tree's height is the difference between the tree's ending height and its starting height. So delta h equals h sub f minus h sub I. So, if Allison measured the tree and it was 6 feet tall, and then she measured the tree again later and it was 9 feet tall, we can say either h sub I plus delta h equals h sub f, so 6 plus delta h equals 9, or delta h equals h sub f minus h sub I, so delta h equals 9 minus 6. In either case, we conclude that the height changed by 3 feet, or that delta h equals 3.